Understanding sklearn's Gaussian process kernels. The product kernel. The product kernel in scikit-learn sklearn is a powerful tool for constructing complex kernels from simpler ones. It plays a crucial role in Gaussian process GP regression and classification, where the kernel defines the prior over functions and dictates the smoothness and shape of a learned model. The essence. The product kernel essentially combines the knowledge of two or more kernels. It works by multiplying the output of these individual kernels, resulting in a kernel that reflects the combined properties of its components. Illustrative analogy. Imagine you have two lenses, each magnifying different aspects of an image. One might focus on fine details, while the other emphasizes broader patterns. By combining these lenses, you create a new lens capable of capturing both minute intricacies and the overall structure of a image. Similarly, the product kernel combines individual kernels, each capturing specific characteristics of the data, to create a more comprehensive representation. Key values in the YAML. Let's explore the key values used to configure a product kernel in a YAML configuration file. YAML. Kernel. Type product. Kernels. Type RBF. Length scale 0.5. Type constant. Constant value 1.0. Type product. This clearly identifies the kernel as a product type. Kernels. This lists the individual kernels that will be multiplied to form the final product kernel. Type RBF defines the first kernel as a radial basis function RBF kernel. Length scale 0.5. This parameter controls the smoothness of the RBF kernel. A smaller length scale leads to a more localized kernel, emphasizing nearby points. Type constant defines the second kernel as a constant kernel. Constant value 1.0. This parameter sets the constant value of the kernel. Understanding the power of the product kernel. Let's analyze the combined effect of the RBF and constant kernels in this example. RBF kernel. This kernel captures local dependencies in the data. It assigns higher similarity to data points that are closer together. Constant kernel. This kernel treats all data points equally, reflecting a global, constant relationship. By multiplying these kernels, the product kernel combines the local insights of the RBF kernel with the global, constant influence of the constant kernel. This allows the model to learn both local variations and overall trends in the data. Application examples. The product kernel offers significant flexibility for modeling diverse relationships in the data. Combining different feature types. You can combine kernels for different feature types. For example, you might use an RBF kernel for continuous features and a string kernel for categorical features. Modeling temporal data. You can use the product kernel to combine a kernel for temporal relationships with a kernel for spatial relationships, thereby capturing both temporal trends and spatial patterns in time series data. Enhancing model complexity. By introducing additional kernels, you can increase the complexity of your model, allowing it to capture more subtle relationships in the data. Caveats and considerations. While the product kernel is a powerful tool, it is not without its challenges. Overfitting. Using too many kernels or complex individual kernels can lead to overfitting. Careful parameter tuning and model selection are essential. Computational complexity. The computational complexity of the product kernel increases as the number of individual kernels grows. Interpretability. The resulting product kernel can be complex, making it challenging to interpret its behavior. Overall, the product kernel is a versatile tool in Gaussian processes, allowing you to build powerful and adaptable models. However, careful consideration of its properties and potential drawbacks is necessary to avoid overfitting. and ensure effective model building.